All right, so we're looking at page 4 here. We have the two basic rational functions and their properties. So the parent function y equals 1 over x looks like this. I can put it in my graphing calculator here. All right, and y equals 1 over x squared looks like this. And we have pre-established domain, range, horizontal asymptote, vertical asymptote, and that it's an odd function. All right. One way to graph rational functions that's kind of convenient is noting what the relationship is between a rational function's parent and the function itself. All right. So if I tell you that rational functions that are of this form will take on a look or a structure of f of x is equal to a over x minus h, sorry, I didn't make my fraction bar big enough, a over x minus h plus k, where h and k give the horizontal shift and vertical shift, and a is the stretch. Could also be the orientation if it's positive. If a is positive, it's going to look like what you see up here. All right. If it's negative, it'll be the reverse. All right. So that's kind of a little trickier to sketch, but it would look like this if it's positive. And let me put it in here. Throw a negative sign on it. It'll be the reverse. So if a is negative, so this helps us avoid things like those test points and things like that. All right, it kind of streamlines the process a little bit. So if I know what the parent function looks like, along with its domain, range, horizontal, and vertical asymptotes, I can look at what I have here. So looking at number 1, I have y equals, if I'm trying to match this up, I have an a value of 1, x minus an h value of 2, and then plus a k value of 0. So a is 1, so that's the standard parent function. Shift, it's going to go to the right 2 units, and it's not going to go up or down at all because the k value is 0. All right, so I'm going to draw some dotted line or dashed lines, and then I'm just going to move them. So normally my asymptotes would be on the axes. That's a little too thin. So normally my asymptotes would be on the axes. I'm going to take my asymptote and shift it to the right 2 units. I'm not going to shift it up or down. And I'm going to draw the sketch based off of this structure because the a value is 1, so it behaves the same way. Always a good idea to get the y-intercept, which is negative 1/2. All right, it gives you a little sense of scale. So we're looking at something, for the most part, like this. As opposed to number 2, all right, the a value is 4, so it's got a vertical stretch. We're going to shift right 1 and up 3. All right, still positive though, so it's going to have the same orientation. But like I said, I'm going to do a couple of dashed lines, and then I'm going to move them, so don't draw them right away. You just draw them where I end up placing them. All right, so I'm going right 1 and up 3. All right, and again, always a good idea to get my y-intercept. All right, I still had it on the dashed line function there. All right, so still get my y-intercept, which is just going to be, if I replace all of my x's with a 0. So 4 over -1 plus 3. So -4 plus 3 is going to be -1. And if you're not sure, just pop it in. All right. It's more about kind of getting an idea of the structure. So it's not out of bounds to use your calculator, so that's fine. All right. Now it's kind of hard to see, but right around here you see the 0, -1, right? But then again, just zooming out or going to auto, you can see that that horizontal asymptote's a little higher than we would have thought. All right. So, and if, you know, based off of the scale, if you're not sure, you could always plot another line for the horizontal asymptote, which should be at 3. Plot that graph and you can see. All right. So 0, -1. So we're looking at something like this. Got to go down and grab that point and then grab this point, or no point to grab there, but you can throw test points in if you're not sure. All right. So number 3 works pretty much the same way. So you could try that one. We also have the other type of parent function, which is 1 over x squared. So if you have f of x is equal to, it's going to have the same build as what we see here, except instead of x minus h, it'll be x minus h squared. All right. So a over x minus h squared plus k. All right. Oh, and by the way, you know, we noted that it had a vertical stretch in number 2 of 4. That didn't really impact the way we approach things. It just gave us a different y-intercept. It kind of forced it to be a little bit steeper. So that sort of works its way out. So you don't have to really kind of like go out of your way to make that fit. All right. We're really just looking for the horizontal and vertical shift. So just going back to this diagram here, this is what a 1 over x squared looks like. Let me do a quick parent function here. So 1 over x squared, lock it in. All right. If I want to see what -1 over x squared is, which is a reflection of that, I can pop that in. All right. So I'll go back to this. But this is what an ordinary 1 over x squared parent function would look like. Domain, range, asymptotes, and this one's an even function. All right, so we're starting off with the same asymptotes, 0 and 0, so y equals 0, x equals 0. All right, make that red. And just taking note of what, well, along the same lines of what we did before, taking note of what our h and k values would be. H is going to be equal to a 4. All right. So, and just kind of touching on that real quick, it's one of those flip the sign situations. All right, because -h is equal to -4. I'll just make a little note here, which means h is equal to 4. All right, the k value is 0, so this is telling me my horizontal shift is going to be 4 units, 1, 2, 3, 4 to the right. All right, same idea here. This one was 2 to the right, and this one was 1 to the right. You see, it was x minus 1, x minus 2. And this one's x minus 4, so 4 to the right. If it were x plus 4, it would be 4 to the left. It's not going up or down. My y-intercept, again, always a good idea to grab that y-intercept. So y of 0 is 1 over 0 minus 4, so -4 squared is 1/16, which is going to put you pretty, oh, sorry, wrong side, put you really, really close to the x-axis. So I know it's going to go through that. And again, this is the x squared, 1 over x squared function, so it's going to be an even function, or it's even in the sense that it'll have symmetry over a vertical axis. All right, so all it is shifted over. So it's going to look something like this. All right. Number 4 is essentially the same idea, except you have a little bit of a higher y-intercept. It'll be 2 over 16, which would be 1/8, but it's essentially going to look like the same graph. All right. Number 6, you're going to go, left, up 3. So start off with my horizontal and vertical asymptotes. I'm going to take my vertical one and shift it left 5. 1, 2, 3, 4, 5. All right, so it's going to go a little off the grid there. So 2 ways to handle that. You could also go off the grid. It's fine because we're going to normally do these freehand. All right. The other way to do it would be to scale it. So if I wanted to go by 2s, maybe I'll do that. So go by 2, by 2. So instead of going up 3, I'll go up 1.5. Instead of going left 5, I'll go 1, 2.5. Grab that y-intercept. So y of 0, 1 over 0 plus 5 squared plus 3. All right, so if I'm going by 2s, it's going to be a little funky, but that's 1/25th. So 3 and 1/25th units. If you want to get a ballpark estimate of that, take that number and divide by 2. So about 1.5 units up. All right, so it's actually going to be a smidge more though. All right, so this one by scale, it would, instead of going up 3, we're going up 3 and 1/25th. That's that extra 1/25th that we're looking at here. So you're going to look at something along these lines. And on the other side, we just want to make it look like a reflection over that vertical line. All right, so we'll talk about this the next time we're in class together. But now with what I just showed you, you could handle all these remaining problems. And that separate worksheet that I gave out, it basically looks like these kind of questions. Previously, it would have taken a little longer to complete based off the skills that we learned, but now you should be able to kind of breeze right through that, I think.